All right. And we are live. Hey, everyone. How's it going? What is the news? I got to move the chat over. All right. I had a good weekend. Camped again. Even though we had the Starlink, I didn't use it. So I just used my terrible cell phone connection and mostly just stayed off the internet, which was really nice. I built some swallow boxes. I moved a bunch of, built some trails. Yeah, it's a good weekend. It's funny when you take time away from the internet and you literally just don't even do anything, you realize how meaningless spending time watching the internet is all the time. Now, obviously, here I am talking to you on the internet. And that, of course, my work here on the internet is totally different, very important. But just like in general, just like the doom scrolling, like you realize just like what a hold it has on your head, which is it's kind of unsettling. And then you spend like 3 days away from the internet, and your brain feels fine, in fact, better. And I came home and I was like cooking, and I worked on a ton of work today. I've been working nonstop all day today, and I feel great. So I think I'm just going to keep trying to do this. Just like no internet on the weekends, I think, is a good thing. Now, I didn't play any video games, so that's a problem. But yeah, apart from that, good weekend. All right, let's get into things. What's a swallow box? It's like a nesting box for swallows. So here in Western Canada, we have a bunch of varieties of swallows. Many of them are in decline. So we have tree swallows, we have cliff swallows, and we have barn swallows. And the barn swallows are like the most at risk. And then they like to live on an underhang under the side of your roof, especially a barn. They build these kind of clay little cups on the side of a building. And so you just need to give them like a nice place that's dry. We don't have that. But a tree swallow, they like a box. They nest inside trees where a woodpecker has hollowed out a hole in the side of a old dead tree. And they like those. And so you build like a little box with a tiny hole, like just an 1.5 inch hole, and they can go in and out of that. And if you're lucky, if you're blessed, and they're very territorial, so you can't put them too close to each other. But yeah, so I'm pretty stoked to get some swallows. We have them all the time flying above our house, but haven't been able to encourage them to come and nest yet. But yeah, and then the other ones are the cliff swallows, and they live on beaches, and they fly a little higher. But yeah, really cool. I love swallows are my favorite birds. I love them. So, all right. Are those birds vaxxed? No. I'm still not vaccinated, although my wife is. I'm supposed to get my vaccination on Wednesday, my first one. So, yeah, roof swifts are related. Yeah, they're all very similar. Such a cool creature. They're like little jet aircraft that fly around. I think that's why I like them. They look like little fighter jets as they fly. All right. I'm going to press record before Chad. Oh, do I have? Oh, there's no card. Okay, hold on. I got to put a card in. Oh, this could be a problem. Let's see what happens. Sometimes this wrecks the focus. I have to turn the camera off and back on again. Let's see if that fixes the focus. That wrecked the focus. Does it still see my eyes? Yeah, focus is still working. Okay. Yeah, just because you get vaccinated doesn't mean that you are completely safe and immune from COVID. You can still get it. We still got to be careful, everybody, until the rates in our areas are down. Okay. Cool. As always, I've got a few questions in advance, and then we will go with those, and then we'll go with the live questions that you're all doing today. Shopping around for a third shot? Can you do that? Yeah, I hear the second shot is rougher than the first shot. Okay. All right, here we go. Hey everyone, welcome to the question show. Your questions, my answers. As always, wherever you are across my channel, if a question pops in your brain, just write it down. I will gather them up and I will answer them here. And just remember, I record this show every Monday at 5 p.m. live. So if you want to be a part of the live show, you just got to go and show up on my YouTube channel, 5 p.m. Pacific time on Mondays. I'm recording this show on Monday, May the 14th. Is that right? May the 17th. Just again. I'm recording this show live on Monday, May the 17th, 2021. So if anything really interesting happens over the course of this week and I missed it, that's because this show is up to a week behind. All right, let's get into this week's questions. Oh, my dog is really freaking out. So just a couple of announcements this week. Let's see. On Friday for Astronomy Cast, we're going to be talking about insight and earthquakes on Mars, Marsquakes. We've got Dr. Ethan Schaller talking about robotics on Mars for the weekly Space Hangout this week on Wednesday. And then next Wednesday, we're talking with Dr. Jay Nadeau about looking for microbial life in space. And tomorrow night, I'm going to be talking, let's see, I've got an interview with Casey Hanmer, who I mentioned this last week. He is terrific. Just talks about all things futurism and space exploration, and I think you're really going to enjoy it. I'll post, it's going to be 9 p.m. Pacific time, so it's going to be at night, and I will post the event shortly. All right. Okay. Yes, I am recording, Chad. Okay. Stephen Clooney. How do we calculate the age of the universe? If we can only see some part of the actual universe and the speed of expansion is accelerating, how do we accurately calculate the point of infinite density at the beginning? Thanks. So, at this point, we know that the universe is approximately 13.7 to 13.8 billion years old, depending on which method you use to measure the age of the universe. And the different methods give you different answers. And for the longest time, this was like people thought, oh, maybe it's somewhere between 10 and 15, 10 and 20 billion years old. But now we have a very accurate number. So how do we have such an accurate number for the age of the universe? And the answer is that we have a very precise measurement of the temperature of the cosmic microwave background radiation. And so I'll explain how this all works. So we know that the universe is expanding. This was the discovery that Edwin Hubble made when he looked at other galaxies, looked at the variable stars, measured the wavelength of the light that was coming from these stars, and noticed that they were all red, or mostly redshifted, which meant that they were mostly moving away from us. And essentially, you can measure, as you look at various galaxies out there, you measure different amounts of redshift, and that roughly tells you the speed at which these galaxies are moving away from us. And so then it's kind of just like a math problem in reverse. You just take the speed that the galaxies are moving away from you, and then you just go, well, if they were a billion years ago, they would have all been closer, and a billion years ago after that, before that, they would have all been even closer and closer. And if you sort of do this backwards calculation, you ask yourself, at what point were all of these galaxies that we can see across the universe in roughly the same spot? That's the Big Bang. And it's a relatively complicated, but it's a calculation that they can do. And that's how they got this very rough number of like between 10 and 20 billion years ago was the beginning, was the Big Bang, was the beginning of the universe. So how do we get this very precise number? So the number that we got is the cosmic microwave background radiation, which is this afterglow that's left over from the Big Bang itself. And it was this time when essentially all of the matter in the universe was hot enough that it was kind of like the surface of a star, like a red giant star. And the temperature was sort of the same kind of temperature that you get if you're looking at the surface of a red star. And like around like 3,500 Kelvin, the sun is say 5,800 Kelvin. The temperature of the early universe was about 3,500 Kelvin. 3,000 to 3,500 Kelvin. Anyway, it was red. And so it was opaque to light. And yet, when the temperature of the early universe cooled down to the point that light could finally escape, there was this very precise number, temperature, that was. And then now, we've been watching the expansion of the universe. We've been watching those first photons get redshifted farther and farther apart until we see them today. And now today we see them as they're way off into the microwave spectrum. The temperature is like roughly 2.8 Kelvin, so vastly redshifted. And so you can essentially, once again, do the math. If you know precisely the temperature as it is that you're looking at it today, and you know precisely what temperature it was when that light was released, you can calculate the difference and figure out how long the universe has been expanding and therefore learn how old the universe is. Now, astronomers have some other methods for measuring the expansion of the universe, and those give slightly different numbers. And so there's still kind of a bit of an argument about what is the correct exact number for the age of the universe, but roughly that's how they do it. Did my audio go quieter? Haven't done anything. Okay. Okay. The Hooded Crow. How stable is the current configuration of the solar system? Will the giant planets ever migrate again? At this point, the solar system is mostly stable. And the reason the giant planets migrated in the first place was because they were still scooping up dust. And so you had the cloud, the nebula cloud, where the sun and all the planets formed out of. And the star formed in the middle of this, and as it sort of all the material pulled in together, it spun up quicker and it flattened out into this disk. And then within the disk itself, the planets started to form, and they accreted larger and larger material. And then they started to spin up, and they started to pull in material from the cloud around them. And as they did that, they started to migrate around within this cloud. And eventually you got to the point where it looks like Uranus and Neptune swapped places, that all of the giant planets moved outward in the solar system. And this was really just in the search of a meal, the forces that were pulling them. And as you got sort of a difference in the distribution of the mass in the solar system, everything moved out. But at this point, here we are 4.5 billion years after the sun and the planets all formed, you've got a relatively stable situation. There's no more gas and dust, really, for the planets to pick up and change their distribution. The sun is roughly what it's going to be. Now, things may change a little bit by the end of the sun's life as it starts to bloat up and change its density. But for the longest time, everything's going to be fine. That said, there still are tiny little interactions, tiny instabilities in the solar system. And I've heard it said that there's like a 1% chance that Jupiter, for example, could kick Mercury out of the solar system through the interactions of its gravity. So, over time, or throw it into the sun. And so there's like tiny little oscillations that could build up. But I mean, here we are, 4.5 billion years after the formation of the sun and the planets, and everything is roughly stable at this point. The thing that's kind of amazing is, as astronomers are looking at other star systems, it really looks like this process happens incredibly quickly. Like, In some cases, planets will come together in the order of hundreds of thousands of years, maybe even faster. So once the process gets rolling, it works very quickly to scoop up and start to form all the material to make the planets. Larry Beckham. After OSIRIS-REx spacecraft discharges its valuable cargo in the Utah desert in 2 years, let me do this again. Larry Beckham. Hey, Fraser. A question has popped in my brain. After OSIRIS-REx spacecraft discharges its valuable cargo in the Utah desert in 2 years, what then for this iconic traveler? It will have some fuel left. Will it still do something interesting? Yeah, so after OSIRIS-REx finishes its mission to deliver the sample cargo that it brought back from Bennu back here to Earth, it's going to do a quick flyby of the Earth, and then it's going to go back off into space. It's still going to have some propellant on board, and it's still got solar panels and the capability to do other things. And so at this point, NASA will give it some kind of extended mission, probably give it some other target to go after, either to do a flyby, or maybe if we're really lucky in the orbits work out, that it could actually do some kind of orbital mission around another asteroid. Of course, it can't retrieve another sample, so it's never going to be able to do that again. But we could get future either multiple flybys or one final home for OSIRIS-REx, or maybe they'll crash it into something. But usually in these situations, NASA comes up with another idea for what to do with the spacecraft. Okay, those were the prepared questions. Sir Goosey is asking, the fungus on Mars, anyone seen that? Yeah. Nobody is taking that super seriously, that there's mushrooms on Mars. Just because something looks like mushrooms doesn't mean that it is mushrooms. Okay. So Chad, if you're watching this, the recording reminder is coming up on every question that I'm posting, so that's a bug. Jeff Sonderman. Hey, Fraser, what are the next frontiers for gravitational wave astronomy? Will we get better detectors? And what might they discover beyond the black hole or neutron star collisions that we've seen? The age of gravitational wave astronomy has really just begun. And, of course, the big thing was to find these giant black hole collisions of intermediate, sort of large stellar mass sized black holes. And of course, now we've also seen a black hole, possibly a black hole collide with a neutron star. We've seen a neutron star collisions. So then you're going to go in both directions. You're going to have collisions between, say, white dwarfs, which are probably happening across the universe as well. We're going to have collisions between much larger, supermassive black holes. We're going to get possibly like the gravitational waves from a supernova that is asymmetrical. And so if the supernova blows off in one direction and does this wobble as it explodes, we should be able to detect those. And then we're going to be able to detect over time these objects as they're farther and farther apart. So right now, when we detect, say, two black holes about to merge, we only detect it, say, in the last minute before the black holes merge together. But imagine if they're farther and farther apart, and maybe we can start to detect them when they are hours apart, weeks apart, days apart. So that's pretty exciting. Then the other thing that we're just starting to get now is this idea of a gravitational wave background radiation, sort of in the same way that we have the cosmic microwave background radiation, that there's a potential for just different wavelengths of radiation. We could get, and it's possible this has already been detected, that there's already this gravitational wave background that we're already seeing, where you've got these black hole collisions happening across the universe, and now we're starting to see the ripples just bouncing around and moving around in space. This is being done through pulsars, and so astronomers have been watching with the Gaia instrument, one of my favorites. They've been watching the positions of pulsars and watching how the pulsars are bobbing back and forth out there in the universe, and they're detecting these large scale gravitational wave background information. And then the one that's really like the most exciting is to be able to detect the primordial gravitational waves. So if you could go right back to the beginning, before the cosmic microwave background, right back to the very Big Bang, when the universe was forming and you had various kinds of masses moving around at high speed velocities, you should expect some kind of gravitational waves being generated by all of this material as it's moving around. And that would answer so many questions. It would tell us it would directly tell us the age of the universe. It would give us maybe a hint of what came before the Big Bang, whether the inflation theory is the right one, or maybe if there's other theories that work better. Were there primordial black holes present at the beginning of the universe? And so there's so many other things that gravitational wave astronomy is going to do. We are just, it's like someone just handed us a brand new scope. This is like Galileo pointing his telescope at the sky for the first time. His first telescope was like 9 power, and he was able to see the rings of Saturn, the moons of Jupiter, the fact that Venus goes through crescent phases, was able to see that the Milky Way is made of stars, was able to see the craters on the moon. This is where we are with gravitational wave astronomy, and it's just going to get better and better and better. Yes, it's a dog pause you hear. Yes, my wife was out actually getting her vaccination, and the dog was not happy about that, and so she was. If you can listen, you can hear sort of snarfs as she was sniffing under the window under the door, because our dog is deaf, so she can't hear. So she works by scent and sight. So she was sniffing under the door to see if Carla was back, and then Carla came and just let her out, and the dog was excited, and so hopefully things will settle down now. Okay. What did I have for lunch? Peanut butter and jam sandwich. Sid Parashar. As the sun is getting hotter day by day and Earth's temperature is rising too, is the Goldilocks zone shifting? If yes, will the shifting Earth by thousands or millions of miles solve the problem? Now, again, we talked about this a couple of weeks ago. The temperature of the sun is increasing, but that increase is like the temperature of the sun is going to, or the temperature of the Earth thanks to the sun is going to increase by about 50 Celsius over a billion years. 1 billion years. So it has no impact on global warming. But in the end, it's going to doom the Earth long before the sun actually turns into a red giant. And so, over time, the Goldilocks zone, the habitable zone of the solar system, is shifting outward. And so right now, it extends from Venus through Earth out to Mars. And in the future, it's just going to keep shifting outward. And eventually, even Earth will no longer be in the habitable zone of the sun. And the solution is, you could move the Earth outward from the sun bit by bit. I think the calculation was to have an asteroid come by the Earth, close by the Earth, once every 10,000 years or so, and shift its orbit out just a tiny little bit. And you would be able to compensate for the increasing temperature that's coming from the sun. And that would let you go all the way out until the point the sun becomes a red giant, and maybe even after that. So if we could master that technology, it would buy us another 4 billion years of nice temperatures orbiting around the sun. Jonas Colden Mitbo, what monopod for binoculars do you recommend? I don't know. I like a tripod for binoculars, not a monopod. I've never used a monopod. I have one, but I haven't used it. What are your new trails for walking on? Although I am going to build some mountain bike trails. I do a lot of trail building. Where I grew up on Hornby Island, we didn't have a lot to do, and so we built a lot of mountain bike trails. If if you actually do a search for Hornby Island, you should even see on Google Maps all of the mountain bike trails that we have. And so where I live now in Courtenay, one of the best places, we have this place called Cumberland, and we have tons and tons of trails. And so one of my favorite things to do is hike, and I love to kind of bushwhack and find new pathways. I like to sort of look at the GPS and figure out how I can get from this location to that location. I find old logging roads and trails, bike trails, connect them up. My legs are kind of trashed actually because I'm all scraped up from bushwhacking through the woods. Sometimes we find bears, but mostly we don't. And I've never seen a cougar. Mystic City, could we be living in an artificial simulation? Yeah, or if you watch the episode that we did, we could be a Boltzmann brain. If you watch the Ken Olam interview that I did, talk about, in fact, we could be a simulation in a Boltzmann brain. Whoa. Dwayne Duvall, you imagine in your last show what it would be like to look up at the sky from a planet near the galactic center. How close could we actually get to still be safe from radiation? It's so if the sun, say the Milky Way is about 130,000 light years across, we're about 22,000 light years away from the Milky Way, and so it's probably within, I don't know the exact number, but like within a couple of thousand light years of the center of the Milky Way. So the vast majority of the Milky Way is habitable. Cryptolicious, did anyone else see that 60 Minutes episode yesterday? I haven't seen it. I don't have television. So if you want to put it on Netflix, I can watch it. But still, I mean, you know, my take on this always is somebody saw a thing. That's the beginning and the end of the story. So it can be an expert, right? A distinguished pilot in the U.S. Air Force or the U.S. Navy saw a thing, used imaged, infrared, camera'd, telescoped a thing, dot, a radar blip, a blurry thing, and that's the end of the story. So that, like, literally that's it. So you can't follow up anymore. So, like, what kind of thing? We don't know. So what do you think? I think that somebody saw a thing. Like, every UFO report is some version of that. Somebody saw a thing. And that is the end of the line. There's no more, everything else beyond that is speculation. And so if you show me one of these things, I'll be like, yeah, somebody saw a thing. It was an unidentified, like literally right there in the name, an unidentified flying, unless it's like going into the ocean, right? Aquatic object. There's nothing else to do. So until there's some kind of evidence that we can use, that's it. There's no more story to give, right? So someone has to provide some more evidence, and then I can give you more information, more opinions. Yeah, the U stands for unidentified. It's unidentified. Yes, I agree. All right, Mark Elkid, are you watching For All Mankind? No, it's on Apple, and I don't have Apple. I'm waiting for my wife to buy a new iPhone, and then we'll get like free access to Apple. Or if Apple releases like a bunch more stuff, then I'll sign up. But I've got so much stuff to watch right now. I watched Oxygen 2 nights ago. That was pretty good. It was kind of a space-related thing. You should watch it. Sort of a cool idea. Cryptolicious volume 2 weeks. The U.S. government agreed to release information. That's great. The U.S. a collection of people are going to release information about a thing they saw. Again, like, can we go to the spacecraft? Can we look inside? Can we talk to the aliens? Can we take a sample of the material? Can we examine some of their devices with a scanner? What can we do? There's nothing we can do. Somebody saw a thing. But like fancy versions of somebody and fancy versions of thing. All right. Horizon Brave. According to your guest, string theory is pretty much dead in the water. Do you agree? Does that put a nail in the coffin of all extra dimensions or string theory based? I don't think string theory is dead in the water. It just is really tough to actually test experimentally. And so after a while, your math takes you to the edge of what you can do. You're pushing math around, but you're not necessarily describing the actual universe. It's only when you do experiments can you actually connect the theory with the universe itself. This is a great question. I don't know the answer, but I want to talk about it because I think it's great. Strange Quark Star. Distant future civilizations will not see the cosmic microwave background radiation and won't know about the Big Bang. Are there already things that we have missed finding out about? Would we know? That's a really good question, and I don't know the answer to this question, but I want to talk about it because I really like this idea. So because the universe is expanding, we're going to get to this point in the far future where all of the galaxies that are not collected gravitationally to us in our local group are going to fall over the cosmic horizon. They will essentially be moving away from us, from our perspective, faster than the speed of light, and their wavelength, instead of just like disappearing, their wavelength will just stretch out and out and out and out, and eventually they'll move into the microwave, they'll move into the radio spectrum, longer and longer wavelengths of radio spectrum. And so it wouldn't be initially obvious right away that there are galaxies out there. And so for future, it's about 100 billion years from now. And so if you're aliens living, and that's, if you live around a red dwarf star, that's not forever. Red dwarf stars will last for up to 10 trillion years. And so astronomers who were born and raised around a red dwarf star may look out into the universe and not see any other galaxies. And so they wouldn't think that there was a set time that the universe formed. But the answer is actually not that simple, because if future civilizations were able to create some kind of radio instrument and watch the sky, they would detect some kind of signal that told them that there was some kind of expansion that was going on. And it might be that they have to make really, really powerful radio telescopes that can handle very long wavelengths that are hundreds of meters long. But there still would be this very faint signal that they probably could detect. And then from there, they could probably deduce that they are living in an expanding universe and try to calculate when the universe itself formed. It just won't be as obvious. So that detection might come thousands of years later than it did for us when they built this galaxy-spanning civilization, and they've got these incredibly powerful telescopes, and they notice this weird signal that's out there. So it's not kind of as simple as that. But then the question is, like, are there things that we won't see? I mean, right now we're so early on in the age of the universe that there aren't things that are completely gone from our perspective yet. But there are things that we've missed. Like, there was a time in the early universe, about 13 million years after the Big Bang, when the entire universe was room temperature. That the habitable zone was everything, which is sort of a cool idea. A couple of billion years after the Big Bang was actually the height of star formation, the time when the most stars were being formed, when the universe was having its party. And here we are, 13.8 billion years after the universe formed, and star formation is down to just a couple of new stars every year in the Milky Way. That's amazing to think that there was a time when it was vastly faster, that there's furious star formation going on in all of the galaxies across the universe. And now things are relatively slowed down now. So I think, maybe in other wavelengths, like maybe if you listened in gravitational waves, the universe would have been louder early on, and now we can just barely detect it. So maybe that's a good analogy. But I don't know. I mean, if you're watching this and you have some ideas, and put them in the comments, because I love the idea of, one of the really weird coincidences is that we exist at a time, if the universe is going to last for an infinite amount of time, from when it formed to when the last, it will never, it will continue to expand, accelerate, and yet here we are at a point that is closer to the beginning. It's a weird coincidence. Now, of course, if you think of it sort of from an anthropic perspective, we could only appear at a time when the universe was closer to its formation, when there was adequate energy to form planets, life, etc. But still, as coincidences go, the fact that the moon and the sun are the same size in the sky is a coincidence. And the fact that we're present early on in the age of the universe, when it will have eventually probably infinite time, is interesting. Nothing else about that. It's just kind of fascinating. A.V. Scott and Flower. Could a powerful enough telescope ever look beyond the CMB? No. No matter how powerful a telescope you have, you could never look beyond the cosmic microwave background radiation, because the cosmic microwave background radiation is a time where every single place in the universe looked like the surface of a star. And so if you wanted to go and look at the sun, you'd be asking yourself, can I look through the sun? Don't try. You don't want to do it, right? The sun is opaque to your telescope and would light your eyes on fire. But let's say the sun was a red giant and you tried to look at the sun with a telescope or some kind of sensor. You would see the surface of the star, and you wouldn't be able to look behind it because the star is a mass of incandescent gas. It is a ball of plasma, and the plasma is opaque in the same way that a wall is opaque. And yet every single part of the entire universe was opaque. And when you're looking at the cosmic microwave background, this time that's like 380,000 years after the Big Bang, you are seeing that in every single place that you look. It's the farthest we can see back. And so no matter how powerful your telescope is, right? If you can look at a wall, no matter how powerful a telescope is, you're still just going to see the wall. And so we need other methods to be able to see beyond the cosmic microwave background. And the only two methods that we know of that were possible was gravitational waves. Gravitational waves were present earlier on in the universe, and probably neutrinos. Neutrinos were present earlier on in the universe, and they were able to escape out into the rest of the universe. And so with really powerful gravitational wave observatories, we should be able to see right to shortly after the Big Bang. And with really powerful neutrino observatories, we should be able to see right to the beginning of the universe. But with regular visible light, with the electromagnetic spectrum, we will always be blocked by the cosmic microwave background. What's the massive incandescent gas reference? Can anyone get that? What is a cock ring? Isn't that from Star Trek? Warp Drive? What kind of jam Raspberry. I like raspberry jam. Zappan, any good pictures of China, from China, of Mars yet? No. No, I mean, not at the time that I'm recording. Maybe somebody knows, but I haven't seen any. And somebody posted this, which I thought was great. Pics or it didn't happen, China. Where are the photographs? So I think we need China to put up or shut up. Come on, let's see the pictures of the surface of Mars from the Zhurong rover. Yeah, they might be giants. Yeah, you got it. The sun is a mass of incandescent gas. Chris March, have you or would you want to interview a physicist about gravitational radiation? Yeah, I think so. I'm going to do probably an interview. I'd like to get someone to talk about this idea of the background radiation, gravitational wave background radiation. Ken Olam briefly mentioned it, but I'm going to find one of the researchers behind this and go into it in more detail. I think it's a great idea. There you go. The surface of last scattering. Yeah, I should use that term. Where are we? Okay. So no, what is the mid state between planets? Whoa. Okay. Andrei Zalukhanov. What if there's no mid-state between planet civilization and some advanced civilization? If we invent something like intelligent AI, it could make the fast transition to something like a planetary-sized mind. It's a great question. It's sort of an interesting thought experiment, but it's actually more terrifying than you think, more troubling. There's this idea of artificial intelligence, this idea of von Neumann probes that we eventually build self-replicating robot probes. We send them off to other star systems. They build more copies of themselves. They go off to other star systems and continue on outward into the universe. And then there's this idea that if we build artificial intelligence here on Earth, then there's this idea of the fast takeoff, that if we can teach an artificial intelligence computer to make a better version of itself, it does so, and then the new version makes a better version of itself. The new version after that makes a better version of itself, and just goes faster and faster at an exponential rate. And they call this the fast takeoff. You're essentially reaching the singularity, this point to which we can't even imagine what the future looks like after we've taught robots to build other robots. And as an advocate who wants to see robots build other robots, maybe I should rethink my position. Anyway, so we'll put these ideas together, and you get this situation where if you develop rapidly expanding artificial intelligence and it's trying to make itself better, then the most useful thing that it can do is essentially turn the entire Earth into one computer. Perhaps there's like the ideal computing substrate. This has been known, it's been called computronium. So whatever is the most, the best way to organize matter to compute. And of course, we can harvest energy from the sun. We've got the rest of the planets in the solar system. And so after the Earth has been turned into computronium, you gather up all of the planets, asteroids, objects in the Oort cloud, etc., turn them into more objects of computronium. Maybe it makes the most sense for cooling to have small objects. Maybe it makes sense for speed, for the speed of light, to have one giant object that is able to compute. We don't know. The computers will figure that out. And then they build seeding probes that head off to other star systems to do the same thing. Maybe they try to bring the resources closer together. Maybe they make sense to leave them farther apart. And eventually you get this situation where you've got these von Neumann probes. You've got this artificial intelligence civilization that's expanding outward from wherever was the beginning point at as close to the speed of light as it possibly can. And that allows it to reach about 4% of the observable universe. So you can reach, like, although we can see the entire universe, only 4% of the universe is reachable. And so these artificial intelligence would realize this, and they would hustle to get as close to the speed of light as they possibly could and try to grasp at all of the resources within this sphere, the reachable universe, and turn it all into computronium, whatever is the most efficient method of computing. So that. Where are we? 546. Okay. Whoa. Bendara, thoughts about the SpaceX Starship orbital test FTC firing? I didn't see that. Did that just come out? That's cool. We're still waiting. I know Elon Musk is thinking of using Starship SN15 to try to go orbital, but I'm not sure if that's going to be the one. Dwayne Duvall, how are the hip flexors at this point, by the way? Getting better. Man, it's a slow recovery, though. So I try not to hike up hills very much. I stupidly carted around a lot of stuff in a wheelbarrow, which was not super smart. Definitely made me feel sore, but not sitting actually is a really good idea. Sort of keeping moving has been really helpful, but not riding my bike, which sucks because I really like to ride my bike. But I'm going to take it kind of easy. Don't get old. Like, do not. Whatever you do, just don't get old. A.V. Scott and Flowers, is there a danger of encountering a mama bear over there? Yeah. No, there's definitely bears here. Normally black bear. We only have black bears on Vancouver Island, and they are they're like big dogs, and you scare them away. But if you get in between a mother and the babies, game over. And so that is the fear that's on everyone's mind, is if you see a baby bear, you are done. You just get away because you do not want the mother to know that you're there. Like, even if you're, you see a baby bear or two, then the mama's around and she's going to be just raging. And so you back away and get out of there. That is so if I see a black bear, I'm like, hello, bear. And the bear sort of blasts off into the forest, and that's the last you see of it. But you see a baby bear, you only want to see that from the safety of a car. That is not gonna lie. That is the thing that haunts our minds living here on the west coast of Canada. I can't even imagine what it's like for the people who live on the mainland where they've got grizzly bears. When I grew up I spent a year in a small town called Kitimat, which is in sort of on the coast and farther north, and the place is just rife with grizzly bears. And it's all my mom talked about, which is like watch out for grizzly bears. People see grizzly bears walking around inside the town, and people get mauled occasionally. And so people just live like that close to grizzly bears. It's kind of terrifying. Oh, I'm hearing everybody's bear stories. Yeah. Oh, yeah. Yeah, not gonna lie. Like if I see just like a regular black bear, it's no big deal. They're scared. They run away from you right away. Oh, that's a good question. All right. Corey S. Is the cosmic microwave background receding away from us? Does it change over time? The cosmic microwave background is receding away from us. And of course, it's like the most distant thing we can see. So if some of the galaxies are moving away from us faster than the speed of light from our perspective, the CMB is moving even faster. It's like the maximum redshift. But the part that's kind of crazy is that every second that goes by and you're seeing the CMB, you're not seeing the same cosmic microwave background. You're seeing the next moment of the universe, the moment that light was escaping from every spot in the entire universe. You're seeing that second of this light escaping, but it's for a new part of the universe that's a little bit bigger. So imagine, 1 second later, you're seeing a new part of the entire universe suddenly being lit. And then 1 second later, you're seeing a little bit more of the universe. And the part that you saw before, that light has already gotten to you. And so you're not seeing that anymore. So whenever we see the CMB, we're constantly seeing, if you just watch it, you're constantly seeing farther and farther regions of the universe that are letting off that first light. It's sort of wrecks your brain to try and think about it. I think Catholic. Yeah. Mum and Cubs isn't the problem. It's getting in between that's the problem. Do they crap in the woods? Do they ever? That's also a little. Actually, that's not so unnerving. But yeah, you run across bear turds all the time, and you can tell how hungry they are because of what they're eating. So you'll see different kinds of berries, and you're like, oh, this guy's he's eating salal berries, or that one's eating thimbleberries or blueberries. And if I've seen pictures of ones that will like flip over rocks in the Rocky Mountains and eat like lichen and mushrooms and things, and you wonder, like, at that point they're getting a little hungry. But mostly the bears here are super well fed. Mark Elkin. Should we pay bounties to remove space junk? Removing space junk is going to be a big problem. It's sort of this kind of crazy idea that right now there's no worldwide regulations for space junk. If you launch a satellite into orbit and then you put it on a really nasty orbit that's going to interact with a lot of other satellites, it's going to stay up for a very long time. There's no rules to stop you from doing that. Now, if your satellite deorbits and it's too big and it crashes into the Earth and it hits somebody's house, you are liable. But if you launch a satellite and it smashes into someone else's satellite and destroys it, there's like no repercussions yet. So our laws for space junk are way behind where they need to be. And right now, you can launch a satellite, you can leave the upper stage just in orbit, and it can just fly around, and you don't care where it is and what it's going to interact with. And with all of the satellite constellations that are going up, with all of the human spaceflight that's going to be happening, with, space, especially near space, is becoming a more and more precious resource. And so we're going to need to get into this age where people have to have this birth to death management of anything they launch into space. Like, if you're going to launch something into space, you have to have a plan for how you're going to bring that spacecraft down at the end of its life. Either you launch it into a very low orbit where it's constantly interacting with the atmosphere and it's only going to stay in space for a few years, decades at the most, and then it's gonna deorbit itself just through friction with the atmosphere. Or you have some kind of mechanism on board the satellite that's going to allow it to deorbit, a tether, a drag sail, something, a retro rocket, something that when you're done with it, it's going to crash itself back into the atmosphere. And I mean, there are already tens of thousands, hundreds of thousands of pieces of junk in space, or working satellites, from working satellites to astronaut gloves to spent boosters to pieces of paint. It's all up there, and it's all moving at tens of thousands of kilometers an hour. Each one is like a little bomb that's going to hit something else and detonate it. And so we need to take this more seriously. It would be really tricky to set some kind of bounty to retrieve space junk. The problem is that in order to retrieve a piece of space junk, you literally have to fire off a rocket mission. Like say there's an astronaut glove that you want to retrieve because it fell off the International Space Station. and it's moving, it's orbiting around the Earth at 28,000 kilometers an hour, and you want to retrieve that glove. All right, so you've got to make a spacecraft. So say the spacecraft's going to cost you $50 million, and you've got to launch it on its own rocket. Say you're going to go with a Falcon 9, so you're going to pay about $60 million for the launch. You're looking at, say, $110 million, maybe $150 million to sort of balance it all out, to send it into precisely the orbit so that it can reach up and catch onto the astronaut glove and grab it. And then the satellite that you sent and has to be able to then deorbit itself to bring that astronaut glove back into the Earth's atmosphere. So it's got some kind of drag sail or some kind of tether that it puts out. You did it. So you got rid of one piece of junk for well over $100 million. Now do that 100,000 times. like this problem is we're well beyond simple solutions to this problem. Now, the idea that I like the best is this idea of like a really powerful orbital laser that shoots pieces of space junk as they go by and ablates a little bit of material off of the space junk, providing a little bit of thrust and causing it to deorbit itself. And so as a piece of space junk goes past the laser, it shoots it, goes zap, 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 and the piece of debris gets these little deceleration bursts that causes it to lower its orbit and eventually crash into the atmosphere. That seems like the only way en masse to deal with the space junk problem in its current situation. But definitely not launching any more junk into space is a really good start. And I'm sure within the next couple of years, we're going to see some kind of global treaty that defines the rules and regulations for launching stuff into space. But it's the same thing with like deep sea. Like once you're outside of the coasts of various countries, there's no rules. There are some rules, but there are less rules, and space has less rules than that right now. You know, mostly people are focused on don't put nuclear weapons in space where you can destroy your enemies instantaneously. Give them an hour's notice as the ICBMs fly across the planet. So yeah, space junk is a big problem. It's getting bigger, and people need to take it more seriously. All right. Yeah, so you just can't. You can't collect space junk en masse is the problem. You have to collect it one part at a time, and each will be its own orbit. So each is its own mission. Now, if you're lucky, you can fire a rocket and go from one, and then it fires its ion engine and gets over to the second one, and then has a little more propellant and gets to a third one. So maybe you only have to do it like 30,000 times. And Nancy, I guess that answered your question as well. Sure. Okay. Jonathan Allen, would there be a use case for launching rockets from Canada, or is it just wishful thinking on my part? No, there's a very good use case for launching rockets from Canada. So the main launch orbit that most people want is they want to go into, they want to launch from the equator. And the reason you do that is because as you launch as close to the equator as possible, you get this speed boost from the orbit of the Earth, the turning of the Earth. It allows you to either launch with less fuel, with less propellant, or it allows you to launch a heavier payload with the same amount of propellant. But there are different kinds of orbits. And so one of the orbits that is incredibly useful is this idea of a polar orbit. So instead of launching around the equator of the Earth, you want to launch around pole to pole. And when you do that, when you go in this polar orbit, then what happens is the Earth is essentially turning underneath your satellite as your satellite is going around. If you time things right, you get a view, you come around, and then the Earth is turned a little bit more, and you get to come around, the Earth is turned a little bit more, and you get this view where you can make this really comprehensive scan of the entire planet. And so polar orbits are very useful. And those are launched nicely from Canada. And so there are plans to potentially build a spaceport out in Nova Scotia. So we might very well see rocket launches happening from Canada. I think that's one of the things that's interesting now. We're seeing more and more spaceports getting built in more countries. Like back in the olden days, you had Florida, the Baikonur Cosmodrome, and that was it. And now we've got in China, in Japan, a couple of them in Russia, a couple of them in the United States, New Zealand, and potentially we're going to see Wallops. You got several rocket facilities in the U.S., South America. And so over time, we're going to see more and more of these ideas. But yeah, polar launches are a thing, and they're very useful. There's other orbits as well. There's like a Russian one they use called a Molnier, which is sort of acts like a geostationary satellite. So you can get, but it's on this really long elliptical orbit where it brings the satellite back. So it sort of, for part of the time, appears to be hovering over the planet, but then the rest of the time is sort of on this long orbit. And it allows you to, sort of see the same spot of the Earth on a regular basis. So there's a lot of good orbits, not just equatorial orbits. Vandenberg. Yeah, I'd heard that Nova Scotia was going to get one, but I'm not sure the state of it. I guess I should interview somebody. I said South America. Yeah, Norway. Okay. All right, I'm going to wrap the main show up, and then we'll stick around for the after hours. So let me just do that now. More questions in a second, but first I'd like to thank our patrons: Stan Senkowicz, Michael Friedman, Bill Christian, Craig Landon, and the rest of our 836 patrons for their generous support. Want our videos early with no ads? Join our community at patreon.com/universetoday. And I'll do an outro. Well, thanks everybody for asking your questions this week. This was a lot of fun. As always, if you're watching this anywhere across my channel, or if you're watching any of my videos and a question pops in your brain, don't hesitate. Just write it down. I read all of the comments and I answer many of them in the chat. But if you want to watch the show live, join me every Monday at 5 p.m. Pacific time on my YouTube channel and just hang out with me live. And also, the show is about 2.5 times longer than the one that you see, the final edited version. So if you want more space stuff, you should join the live show. And then I'll do the outro. If you want a single comprehensive resource for space news, you'll want to subscribe to my weekly email newsletter. Every Friday, I send out a magazine of space news with dozens of stories, pictures, brief highlights about the story, and links so you can find out more. Go to universetoday.com/newsletter to sign up. It's totally free. And did you know that all of my videos are also available in handy audio podcast format so that you can have the latest episodes as well as special bonus material like interviews with me show up on your audio device? Go to universetoday.com/audio or search for Universe Today on iTunes, Spotify, or wherever you get your podcasts. And I'll put a link in the show notes. Thanks to all the moderators, and a special thanks, as always, to Chad Weber and Nancy Graziano. All right. Uncle Bill Druin. Oh, I missed it again. Ask your question, Bill. You're fired. All right. Turn off that recording. Turn off that recording. Okay. Boom. Let's go. The fact that the gravity wells are for sucker sign, it's on the floor instead of the door. I know, it's right here. I should just hold it. Here you go. I'll just hold the sign. How about that? There you go. All right, we'll continue. No. I'll put it on my desk beside me on top of the giant pile of unread books. And is that better? Turn off warp speed, or we turn on warp speed. Joe, why are Europa's cracks orange? It's possible that there are organic materials that are coming up through the ice. We don't really know right now. Pay boundaries for space junk. Okay, we covered that. T260, is there any way to harvest the high energy particles in space? Something like solar panels for the sun? Not that we know. We don't know of a way to harness the power of high energy cosmic rays, things like that, hitting you. Larry Beckham, what makes this section of our galaxy a habitable zone? So, not intense radiation at the core of the galaxy and adequate heavy elements, which we don't see in the outer galaxy. So we've got not radiation and plenty of heavy elements. I recommend a tattoo. Yeah. There you go. Whoa, I don't know. A.V. Scott and Flower is asking about the concrete at the starbase. I don't know the answer to that question. Why is it so uneven? Isn't that dangerous? I don't know. I haven't looked. Is there a video on this? Andrew Planet, is the stuff from older generation stars that makes up protoplanetary disks made out of stars that existed previously in the same region? Mostly stars are made up of primordial hydrogen and helium left over from the Big Bang, and then it's seeded with heavier elements that were blown off through outgassing of stars or from supernova or colliding neutron stars, enriching the clouds with additional material, and in some cases causing the actual collapse that leads to the star. Pick up the webcam and show us around. I can't because I don't want to, like, it's all set up pretty nicely, and it's just piles of junk. You don't want to see the rest of the room. A.V. Scott and Flower, will James Webb be used to look at the planets? Yeah, absolutely. All right, let's go for some of the new ones now. Roger M. Could black holes not destroy information and is stored in the black hole's orbit, spinning near light speeds? Possibly. I mean, the fact that black holes are thought to destroy information and then evaporate again is a puzzle, and we don't really know what the answer to that is. That's why it's called a paradox, the information paradox. So every now and then someone says, oh, I think I've solved the black hole information paradox, and then they don't know. Visto Tutti, did I hear right that James Webb is delayed again, not launching Halloween? Possibly. So the problem is that the last two Ariane 5 rockets that, James Webb is going to be launching on an Ariane 5, and the last two of them had problems with their launches, and so NASA is understandably a little concerned that the Arianes aren't as reliable as they once were, and so they're asking for a very detailed, NASA's GAO is asking for a very sort of detailed investigation into the safety and if there's any issues, like why did these Arianes fail, and so that might cause a delay. So we'll see. It would suck. Did SpaceX hide the release of their Starlink satellites because it showed the bracket release being space junk? I don't think so. Did they hide the release of their satellites? I mean, the thing is that the bracket is going to be in the same orbital parameter as the Starlinks themselves, and they're not even raising their orbits, so they're going to, any additional hardware that's released in space is going to deorbit itself within months. So the great thing about the Starlink level and below is that it's self-cleaning. People are always concerned about space junk, but in fact, things like Starlink are a push in the right direction. Bring the orbits down. Don't push up higher. OneWeb is the OneWeb satellites will last for a long time, decades, while the Starlink satellites, they're so low, 500 kilometers, no, 300 kilometers. Anyway, they'll deorbit themselves within a year or two without constant thrusting to keep themselves at that right altitude. So that's the trick. Busted Rav, is it correct that if we were able to travel instantly to the edge of the observable universe, we would just see more universe? So what does that mean for the Big Bang? Is that only a portion inflated? Yeah, that if you went to any part of the universe, of the observable universe that you can see right now, you would see roughly the same thing. You know, the galaxies would be in different configurations. You'd be seeing more of the universe, but you could then you could pop to the edge of that observable universe and you'd see the same thing, and you'd pop to the edge. It's universe in all directions, and we don't know how big the universe is. So it might be that eventually you would wrap back on yourself, you'd return to your starting point, but we just don't know how big the universe is, and it might be infinite. But yeah, everywhere you go, there'd just be more universe. So the Big Bang happened everywhere. Did you watch the video that I just posted? I talk about that. YouTuber How To Basic? I don't know what that is. Do I have a favorite question? I don't. Dwayne Duvall. I have answered tens of thousands of questions at this point. They all blur. I like the new questions, the questions I haven't seen before, which doesn't happen very often, and that's why I treasure them. There you go. Nancy Graziano, Starlink is 550 kilometers. I love that Nancy is able to post her comments to me by forming them as questions that I then see in the system. Very clever, Nancy. Man, my guess on the next big astronomy discovery. This Cujo and Friends. Man, there's so many. But I think the one that's tantalizing and interesting is this idea of this. I've talked about this gravitational wave, this background gravitational wave that's happening everywhere, and that is that's pretty exciting. That we're going to be able to start to detect just the overall, just the sound of black holes smashing into each other across the entire universe, and it's just barely detectable by looking at the positions of these neutron stars and as shifting back and forth as gravitational waves are washing over them. There was another paper that I looked at just today about how you could use gravitational wave lensing. So beyond just detecting gravitational waves, but actually detecting how gravity is lensing gravitational waves. So you could detect gravitational waves through gravity, which is super weird, but really clever. So I like that a lot. So there's a lot, man. There's so many. I mean, if you read Universe Today, and better if you get my newsletter, and this is me advertising the newsletter, what the newsletter really is me, like half of the newsletter is the stuff we're writing on Universe Today. And that is all of the writers pick the stories out of the big list of stories that I offered them, and they wrote about them. But if you go down to the bottom of the newsletter, there's like another 20 or so links. And if you sort of put the two together, you get the links at the bottom plus all the stories that we ran on Universe Today. That is like, if you could compress that down, that is, what is Fraser interested in? is what is Fraser curious about? What is Fraser thinking? What is catching Fraser's eye? That is the sum of that whole newsletter process. Because the way the system works is I go through all of my news sources every day, and I pluck out all the stories that I think are interesting. I skip stuff that I'm not interested in, and then I run them through my Twitter feed and give each one a chance to sort of see if like people are interested, see what people are thinking about these ideas. And then we feed them into this publishing system for the writers. And then the writers look through all the stories and go, oh, I'm interested in this story. I'm interested in that story. And and they choose. So I don't assign the stories to the writers. I give the writers all the stories. And so Paul Sutter likes cosmology questions. So does Brian Koberlein. Matt likes sort of spaceflight questions. Nancy really likes like NASA exploration stuff, articles, etc. And they pick their favorite kinds of stories. But in the newsletter, you're essentially seeing all the stuff that that the writers chose, but all the stuff that the writers didn't choose. And if you collect that all together, that is all of the stuff that I'm interested in, all of the things that I think are really clever ideas. But we just don't have enough resources to write everything. Joshua Bingham. A rock would not be able to comprehend what consciousness is. If humans are this metaphorical rock, do phenomena exist within the universe that are too foreign for our intellect to comprehend? I get this question a lot, and I don't buy it. I mean, sure, there could be things that we can't comprehend as intelligent, but are actually intelligent. But the universe is made of energy, and the universe is made of matter. And so what we see here on Earth is all beings, whether they're intelligent or dumb, all living creatures, essentially competing for energy and matter. Plants, ants, foxes, birds, us. And of course, because we're the most intelligent and we figured out how to sort of enslave the rest of the planet, we're the ones that are coming out on top of this battle for energy and matter. And so we would, like, an ant sees us and knows that we're a threat and will bite us. Now, the ant doesn't comprehend our intellect, our vast intellect, doesn't really truly appreciate what kind of damage we can do to an ant nest. But it definitely perceives us, knows we're here, possibly sees us as a threat for its resources, So I think that in that same way, if we saw something out there in the universe utilizing either energy or matter or both, we would perceive it working in some way that seems to be intelligent, that isn't just planets going around stars, that there's something going on the surface of the planet, in orbit, moving around the solar system. And so if it's not doing that, then we can't detect it. And if we can't detect it, then it doesn't matter. Like, it's just like, is it even there? Right? If it's a ghost and we're not competing for energy and matter with this other life form, it's not interacting with us in any way, shape, or form, we have no way of detecting it, it's not a hindrance to us, it might as well not be there. So could that be the case? Sure. But then who cares? Yeah, I mean, are there things that we can't perceive? Probably. When we look out into the universe, are we seeing the true nature of reality? Probably not. Who cares? We can only see what we can see, and we can improve our methods of detection into other wavelengths. We listen to black holes crashing into each other. That's amazing. That's us extending our senses into other dimensions. If at some point we start to hear the cacophony of aliens interacting through gravitational waves, then we will start to get a sense of the true nature of reality. But if we don't, but again, gravitational waves are mass crashing into each other. So I don't think that, people always ask this question, like, what if there was like a dragon man and we couldn't see him and he was invisible and we couldn't hear him and he didn't give off any electromagnetic radiation. There was no way to detect it. Aren't we just dummies? No, we're not. We're doing the best we can with what we got. We're finding what we're finding. So Okay. Take another couple of questions, then we'll wrap this up. I would like to bite an alien. It's never aliens. Let's see, one more. Horizon Brave. Do you think that Space Force will eventually spur on more orbital regulation? I don't think Space Force is going to be the one that will spur on. They're going to be the enforcement of orbital regulation. But the way you enforce orbital regulation is down here on the ground. You have international treaties and lawsuits and fines for companies that break the rules. So if the United States sets a rule that no spacecraft is allowed to, like right now, there's already regulations for, say, the FCC for telecommunications. And so if you launch a satellite that communicates in a way that it's not supposed to, using wavelengths that you're not allowed to, then the FCC will shut you down. They will fine you. They will shut your business down. They will tell you to turn your satellite off. And so you can imagine similar issues if you launch and you don't sort of think about the space junk. All right. Cool. All right. I think I'm wrapped up. So thanks, everyone, for joining me today. This is super fun. Like I said, tomorrow night, 9 p.m., interview with Casey Hanmer. He is awesome. You are going to love, if you check out the previous interview that I did with him. He's one of my favorite people to talk to. He'll talk about the implications of what Starship means, of sending people to Mars, et cetera, et cetera. So that'll be tomorrow at 9 p.m. Pacific. So it's going to be a late one. All right. Thanks, everybody. And we'll see all of you next week. Or Wednesday, or Friday. So many shows. Join us.